All right, so this is the first screen you'll see when you go to the simulation. And can you guys still see my little camera box on the side, or you only see my shared computer screen?
We can only see your shared.
Okay. Well, if you have the lab pulled up on another one of your screens, let's go through that. So what we're doing, what I'm going to show you guys is, I'm looking at the very first, this is the second page of the lab, and it's going to say, it says page 6, but it's on the second page of the lab after you've pulled up the simulation. And it's the first table you see that you're going to have to fill out. And what's going to happen now, guys, is I'm going to put you guys in breakout rooms. And in those breakout rooms, we're going to do these labs together. So it's going to be similar to like what we do in class, where I put you guys in groups of 2 or 3. And then you guys would work on the lab experiment together. You fill out the table, answer the questions, turn it in at the end of class. So that's what I want you guys to do for today's lab. But I want to talk through what the lab is saying. So the first table, it says on the procedure, it tells you, it says select custom under the blocks menu. So that's the very first step that it says. The blocks menu that they're talking about is this menu over here. You guys see my cursor where it says blocks?
Yes.
And so we're going to select custom. It's already selected for us. And then that's step 1. That's all you have to do. Step 2 says complete the table below and answer the questions provided by varying the material of the block. So it says it's important, pay attention to the values that are already filled in. And then it says take a screenshot of the density information for any 2 of the blocks listed. You don't have to do that. So what we're going to do is we're just going to look at this first table. And when you look at the first table, the first thing you see is styrofoam. So to get to styrofoam, I'm going over here where it says wood, and I'm going to pull this drop down button, this drop down arrow, and I'm going to click on styrofoam. And it's going to give me a piece of styrofoam that's in this water right here. All right, so I have the styrofoam, and it says, let's just fill out the table. So the first block of styrofoam, it says under mass, it tells me that my styrofoam has a mass of 1.60 kilograms. This is all from the table. So to change the mass of the styrofoam, I'm going to go over here to where it says mass, and I'm either going to drag this over to 1.6, or I can just go over to the block right here and type in 1.6. All right, so if I type that in, press enter, it's going to give me a volume of the styrofoam. If I change the mass, it's also going to change the volume to 10.67 liters. That 10.67 liters is what I'm going to write down on my table, because that's a missing blank in my table. I'd write down 10.67 liters. You see right here that it says that means that the density, when you divide these numbers, the density is going to be equal to 0.15 kilograms per liter. So what that means is, I know I've been telling you guys, let's make our units in grams per milliliter. In this table, they're asking you to write your density in units of kilograms per liter. So we're going to write it all down. We would literally just write down 0.15 kilograms divided by liters. This is still a measurement of density, because all it is a mass divided by a volume. All we did was take this mass and divide it by this volume. We get this ratio, which is 0.15. We just have to specify what our units are. So then the last column of the first table says, oh, does this piece of styrofoam, does it sink or does it float? And in this case, it's going to go ahead and it's going to float. And it makes sense that it floats, because we know that the density of water is what, guys?
More.
It's 1. So the density of water is more dense than this density of styrofoam, just because we can see the numbers are different. And then it makes sense that it floats. So I'm going to stop sharing my screen so you guys can see your labs in front of you. So,
Professor, how are we supposed to, should we just write this on like a different document and then turn it in that way?
So what usually happens if you don't have it printed out or if you don't have a computer monitor or a tablet that you can write on, there's somebody in your group that does. And I only want you guys to turn into one lab procedure per group. So hopefully the other person either has it printed out or has something that they can write on, like a tablet that they can write on and just save it as a PDF. So I'm gonna get to how we submit it though. Give me a second. All right, so does everyone see? Let's look at our lab procedure. I'm on the second page here. Does everyone see how I got these numbers? So I just had to change the custom, the block setting to custom, and then I picked styrofoam. That was my first block that I'm using. I changed the mass to 1.6 because that's what was given in the table. I wrote down the volume that gave me. And then I saw that the density actually matched up, and I saw that the piece of styrofoam actually floated in that tub of water. So you have to basically fill in all the blank spaces. So we changed our drop-down arrow from styrofoam to wood in the next table, in the next one. We see that it gives us the volume instead of the mass. So now we're adjusting the volume, and we have to fill in what the mass is going to be and then write down what the density is. So we should be able to still calculate these two and see that we get the same answer, but then write down to the sink or float. So does this make sense to everyone for this first table?
Yes.
All right, it's pretty straightforward.
How will we get the mass for wood? So we put like.
They're gonna give you the volume. So
Yeah.
they give you the volume and you change the volume instead of changing the mass. For the styrofoam, we changed the mass.
And then we
You see what I mean?
calculate.
Okay, so basically you just have to pay attention to the numbers that are already given to you and then figure out the other numbers. Now down here it says in the space, show all calculations for each step. I don't need to see every calculation, guys. One example calculation, for instance, like the styrofoam or the wood, if you just show an example calculation that says mass divided by volume gives me this. In reality, this should say 0.150 kilograms per liter because we need 3 sig figs and this is 4 sig figs. Remember, we're dividing the two. Remember, we want to keep up with our sig figs. So showing one calculation is I'm satisfied. And then after you fill out this table, we go to the next table. And we're going to follow the same steps of the next table, but the next table says we're going to change our block setting to the same mass. So I'm going to share my screen one more time. I want to talk through this table right quickly, and then I'll set you guys up in breakout rooms. So let me share my screen one more time and talk through how we do table number 2. All right, so for table number 2, it says, now we're gonna change our block settings from custom to same mass. So I'm clicking on same mass here. When we click on the same mass, it says in the chart, write the mass of the blocks pictured. So we have to first write down the colors of the boxes. So the colors of the box, blue, yellow, green, red. You know, we're gonna write those down and we're gonna go in order. So if I start off with yellow, well, it then says we have to write it in lowest density to highest density. So you might wanna, you can write it and then maybe just write it on a separate sheet of paper so you make sure you put it in the right order. So yellow, it says that the mass is 5 kilograms. So if you notice, every block has a mass of 5 kilograms, so I can just automatically write 5 kilograms in all of the mass of box. Everything's gonna have the same mass because that's the setting we put it on, same mass. Now we're just simply trying to figure out the volume and the density. Now in this case, to figure out the volume, we're gonna take one of the blocks one at a time, and it says drag a block into the 100-liter tank of water. So if we see that this tank of water has 100 liters in it, what we're doing here, this is called water displacement. And all water displacement says is we can figure out the volume of a substance if we put it in a tub of water and then we measure the difference in the rise of the water. Meaning, if I take this yellow block and I put it in the water here and I hold it down at the bottom, we have to click it and hold it to the bottom because if I let it go, it's just gonna float to the top. So I wanna make sure I grab it and I hold it down at the bottom like I'm holding somebody's head down or something. And if you see, you pay attention to the volume changed from 100 liters to 110 liters. So in this case, can you guys tell me how much the volume increased?
10.
10 liters.
We see that it increased 10 liters. So all that really means is that the volume of this block was 10 liters. And that's what water displacement is. You're gonna have a tub of water. The tub of water was initially 100 liters. We put the block in, we held it underwater. The water increased 10 liters. So that means the volume of this block is 10 liters. So for the yellow block, I write down that the volume is 10 liters. And then when I go to calculate the density, I just say 5 kilograms divided by 10 liters and get the density that way. Now remember, once again, we are still keeping up with our significant figures. When we keep up with our significant figures, we see that this is 2 decimal places minus 2 decimal places, because we're going to do 110 minus 100. So we should have 2 decimal places when we're writing down 10 liters is what I'm saying. So that subtraction rule says the least number of decimal places. And then when we go to calculate the density, we will end up having 3 sig figs divided by 4 sig figs. Our answer should be in 3 sig figs. So we're going to do that for each color. And let me stop sharing for those of us who don't have it printed. All right, so you guys following what I'm saying so far?
Not really. So you said that, okay, so the volume of the box was 10, right? I got that part.
Okay.
And then you said something about sig figs, and that's when I got lost.
Okay, so but you understand what to do with the blocks. That's
Right.
the main part I want to get. If you're stuck on the sig figs, I can come in each group and talk you through the sig figs, but
Okay.
you understand what to do with the tables. That's what I want to make sure.
Yeah.
All right, but to quickly go over that question, remember the rule for subtraction with sig figs says the least amount of decimal places. So if I have 2 decimal places minus 2 decimal places, my answer should have 2 decimal places. Do you see what I'm saying?
Yeah.
All right, that's the only thing I was saying with putting the 10. So now when I calculate my density, I'm saying 5.00 kilograms divided by 10.00 liters. And now the sig fig rule says 3 sig figs divided by 4 sig figs. My answer should have 3 sig figs. You see what I mean?
Yeah.
Now, when you put that in your calculator, it's going to say 5 divided by 10. It's going to give you 0.5. Do you guys remember what to do to get 3 sig figs in this case? Because 0.5 is only 1 sig fig. What's that?
You do the scientific notation.
Yep, you can do scientific notation. If I write it in scientific notation, we could say what?
You can add 0.
5.00.
You can add 0.
Yep, okay, so it's 2 things you can do.
0.50.
You can say that this is just equal to 5.00, and I'm just
Yes.
gonna say E, what's that? -1. Or we can just simply add 2 zeros. Even though the calculator doesn't show those zeros, you can just know that those are zeros afterwards.
Gonna just be adding 1 0 because it's 3 sig figs.
Remember, this first zero is not significant,
Oh, okay, thank you.
okay? All right, so, I mean, the trickiest part of this is just keeping up with the sig figs, guys. I think the simulation is very straightforward of what you have to do. The next table the next table, we're gonna end up changing our block setting to same volume versus same mass. So same volume means the volume's gonna be the same instead of the mass being the same. And then we're gonna figure out the table. You know, we're just gonna read the directions and figure out the table. And then finally, this last table says that we change our block setting to mystery. And when we change our block setting to mystery, we have to basically, it's gonna give you different colors of the boxes. We then, let me just share my screen one more time just so it's clear, guys, on this last table. All right. I'm gonna share my screen one more time. We're gonna go over here and we're going to change our block setting to mystery. And when we change our block setting to mystery, it says, let's just go with each block. I'm gonna start off with E because it's on top. We're gonna first take the mass of E. We put it over here on the scale, take the mass, write down the mass of E in kilograms. We then are gonna take the block E, we're gonna put it into the tank of water, hold it down, measure the volume of E. We see, can you guys tell me what the volume of E would be in this case?
101 liters.
1 liter, we see that. All right, so we know the mass, we know the volume. We can divide the two. When we divide the two, we get the density. We say whether it sinks or floats. In this case, it's going to sink. And then when it says write the identity of the box, all we have to do is go to show table. And it's gonna say, these are the different boxes that this could be. Write down the one that matches up with your density. So when we calculate the density of E, we should be able to find what the block is in this case and just write down what the identity of the block is. Does that make sense, guys?
Yes.
Yes.
Okay, all right. So in this case, that's all we're doing for the last table, nothing confusing. It's just saying, basically take the mass, take the volume, calculate the density, and then say what the identity of the box is. Once again, just remember, I only need one example calculation. So that's what I'm gonna write here, one example calculation. You do not have to show all the calculations down here. So one example calculation. And then finally, the last part says we're gonna answer these questions. So we have about 10 problems we're gonna answer. Now, some of this we haven't quite gone over. We're gonna go over on Monday, but I still want you guys to just look up the answers because I think they're pretty straightforward questions. It's gonna say, you know, write the definition of density, tell whether density is a physical or chemical problem. You're probably gonna have to look that up. Most of us don't know that. Same thing with an intensive or extensive property. You can just look that up in your book or you look it up on Google, and then it gives you some example problems where you have to calculate the density. It's a little weird. It says if an object has a mass of 30, this should have 30.0 grams, not 300. This should say 30.8. Let me write it in pen so it's clear. So this should say 30.8, 30.0. Same thing with number 5. It should say 19.5, 20.0, 3.10.
So we don't have to turn in this post-lab questions?
We do. You have to turn it in. You're gonna have to turn it in with your assignments, with the tables. So these are due today in class. I know it seems like a lot, but the table shouldn't take you guys but like 30 minutes to do, and then maybe another 30 minutes on answering the questions. So you guys have, you know, the next class still goes on for another 2.5 hours. If you work together, it should take you guys about an hour to complete this. Some of us can complete it a little faster, some of us a little slower. I'm gonna be jumping in and out of the rooms to help you guys. And then if we go to this next page, I've crossed out number 10. I think that it is an unnecessary, confusing question. Like, I like the question, but it's not worded properly, and it gets really confusing. So we're gonna cross out number 10. You don't have to do number 10.